if more people trickle in, that's good too. Hi everyone, thank you for joining us today for this presentation of Words Writers and Southwest Stories. Today we have Eric Wagner, who's giving a presentation on After the Blast, the Ecological Recovery of Mount St. Helens. My name is Tasia Williams, and I'm the curator of the Southwest Seattle Historical Society. And just before we begin, I want to acknowledge that the Southwest Seattle Historical Society and the Log House Museum sits on the lands of the Duwamish people, past and present. And with that, I will hand things over to our chair of this program, Dorothy Hendricks.
Welcome back, everybody. Thank you, Tasia. Tonight, you've seen advertised, I trust, that Eric Wagner is our presenter. Eric is a scientific environmental writer in Seattle, where he lives with his family. 4 years ago, he was guest speaker for our Words Writers in West Seattle and presented Once and Future River, Reclaiming the Duwamish. 2 years ago, he presented Penguins in the Desert, showing Magellanic penguins in Argentina, which was a very popular and entertaining presentation. He earned his PhD from the University of Washington for the research on that book. Since then, Eric's been involved with restoration efforts on the river and worked on the book he's presenting tonight, After the Blast, the Ecological Recovery of Mount St. Helens. While climbing Mount St. Helens every year, Eric has witnessed and reported on the environmental events Mount St. Helens has been surprising scientists with ever since the blast in May of '80. Tonight, Eric will take us on a fascinating journey through the blast and beyond. From fireweed to elk, the plants and animals seen would not just change how ecologists approach the eruption and its landscape, but also prompt them to think in new ways about how life responds in the face of seemingly total devastation. Eric's essays and journalism have appeared in Audubon, Orion, Smithsonian, High Country News, and Earth Island Journal, among other places. His other areas of interest are science and nature writing, creative nonfiction, and more. Eric says that he has spent a lot of time worrying about how humans are or are not willing to share the planet with its non-human inhabitants, and it's obvious he continues to be very involved in how the environment responds to all that we're doing to or have seen happen to our planet. Welcome back to Words Writers and Southwest Stories, Eric.
Thank you, Dora, Faye, and thank you to the Southwest Historical Society and just for hosting me. And thank you all for joining me for this talk remotely as the world burns. And so tonight, as Dora Faye said, so I'm going to share my screen. Tonight, I'm going to talk to you about After the Blast, another time when there was a massive environmental sort of conflagration, and how, let me shrink this down, there we go. And sort of how to talk about ecological resilience and ecology and things like that. So without further ado on this, I guess we're a little bit past the 40th anniversary of the eruption. So this is what Mount St. Helens looks like today when seen from the Mount Margaret backcountry a little bit to the north. It actually might look a little bit like this right now because you can see on the horizon there's some haze from wildfires. But this is, in the Pacific Northwest, this is a real sort of iconic landscape, the crater and the sort of the blast area around it. And everybody sort of remembers, everybody who was alive in 1980 really remembers where they were when Mount St. Helens erupted. And as a result of this, the story of the eruption of Mount St. Helens is in many ways it's a familiar story. And so one of the things that would happen when I was working on this book, I would tell people what I was writing about the eruption of Mount St. Helens, and they would say, oh, cool, what are you gonna say that's new? And that question always sort of took me aback, because at the time I was reading as many scientific papers and reports as I could get my hands on. I was talking to all these scientists who had been studying the mountain, some of them for, since the eruption, so for almost 35, 40 years. And most of what they were telling me was new. I was really struggling with trying to sort of synthesize and understand everything they were telling me. And so to be asked, what are you going to say that's new? I was like, oh gosh, it's all new. And so tonight I hope to tell you some things about the eruption, about this familiar place that sort of put it in a newer light. But first I want to sort of situate the mountain for you. So Mount St. Helens sits in what's sort of colloquially known as the Pacific Ring of Fire, which is a 25,000-mile arc of volcanoes and sort of tectonic activity that runs from the southern tip of South America up through Central America, through North America, through Alaska and across the Aleutians to Russia and down through Japan, in Malaysia, Indonesia, before ending down in New Zealand. And there, along this ring of fire, this arc of activity, are hundreds of volcanoes. I mean, every little black dot that you can see in this picture is a volcano, and about 400 of them are still active. And so within the sort of ring of activity, Mount St. Helens is one of the Cascade Range. It's part of the Cascade Range, which is a series of 18 volcanoes that go from southern Canada. So this is a photo from or an image from the US Geological Survey. So, you know, Canada apparently doesn't exist to them, but the Cascades run from Canada to Northern California, and there are 18 of them. And among the Cascades, Mount St. Helens is the youngest. It's a vent, the vent over which the sort of prominence sits is about 40,000 years old. And the part of the mountain that we can see, what we consider the mountain or the prominence, is itself only about 4,000 years old. And so in geological terms, Mount St. Helens is just a baby. And it is a very squawky baby, as babies can sometimes be, being easily the most active of the Cascade volcanoes and erupting on average about every 140 years or so. So not that you necessarily would have known this in 1980, at the beginning of 1980. So this is a photo of Mount St. Helens before it erupted, obviously. And you can see its peak was gorgeous. It was it was known for its beauty. It had been called kind of Fuji of North America. And the reason for that was that it's the sort of perfect symmetry of its peak. And the reason for that perfect symmetry was its youth in part. Because it was only 4,000 years old, glaciers hadn't had time to carve it up as they had at nearby Mount Adams or Mount Rainier. But human and geological time horizons sort of started to converge in the spring of 1980, when in mid-March, a series of small earthquakes signaled to geologists that magma was on the move up into the prominence. And over the course of the next several weeks, a magma chamber formed in the north flank of the mountain. And so magma was filling it, and the chamber was expanding. The north flank began to bulge. It was actually called the bulge, and it was expanding by as many as 5 feet per day. And so through March and April, there were occasional steam eruptions. A crater opened on the summit and was soon a few hundred feet in diameter. There were cracks on the summit. And all of this, led geologists were sure that something was going to happen. Something was going to happen at Mount St. Helens, but they couldn't say what precisely, and they couldn't say when precisely. And then in May, at the beginning of May, Mount St. Helens, after all of these sort of small shudderings and quakings and steam eruptions, Mount St. Helens went very quiet. And so this is what Mount St. Helens looked like on the morning of May 18th, 1980. And this is a photo taken by Gary Rosenquist. And what I'm going to show you is a series of photos that he took right at the moment of the eruption. So this photo he took at 8:27 in the morning. And at 8:32 a.m., a large earthquake struck the mountain and the north face collapsed. The summit and the north face sort of rippled, churned, and then collapsed in what at the time was the largest landslide in recorded history. And so billions and billions of tons of rock and sort of glacial ice and snow and organic debris plunged down the mountain. And when the north flank collapsed, what that happened was all the pressure that had until then overtopped the magma chamber was gone. And so all of this superheated water and gas that had been sort of contained by the weight of the mountain was suddenly released. And so the water flashed to steam and exploded out in what is called the lateral blast. And so Rosenquist over the these are just seconds, within about 30 seconds, this is what the mountain looked like. And so Rosenquist, he was taking these pictures from a place called Bear Meadow, which is, it's about 11 miles away from the east. And what I'm going to show you now is a GIF of what the lateral blast looked like from the west. So you can see it just, clouds exploded out and they raced over the land at several hundred miles an hour. And as they traveled, they just flattened every tree that they hit. So, the landslide rumbles down, the lateral blast explodes out. And so when it was gone, ash began to billow from the new crater. Just a column of ash climbed about 15 miles into the sky and began to blow east with prevailing winds, and coated a major portion of eastern Washington with ash, and sort of roughly akin to the wildfire smoke that we're seeing now, except on a sort of a much greater and more concentrated scale. Geologists later estimated that about 500 million tons of ash was emitted during the main sort of catastrophic eruption. And it blew east, and eventually detectable amounts of ash would be found in 17 states. And then the cloud rose up into the stratosphere and circled the Earth in about 2 weeks. And so while this was happening, while this giant ash column was billowing up into the sky, there were pyroclastic flows. So that was when pumice rock sort of frothed over the edge of the new crater and flowed down the north flank of the mountain onto the land and into the lake that sat in front of it. And so the main eruption lasted about 9 hours. And by the time it was finished, this is sort of the landscape that was left. This is a photo taken a couple of weeks later. And Mount St. Helens had shed about 1,300 feet in elevation. So it went from being about almost 9,700 feet tall down to about 8,300, a little more than 8,360 something, I think. And there was a crater in the mountain that was 1 mile wide in diameter and over 2,000 feet deep. And so, but one of the things about the eruption that really had caught geologists by surprise was the fact that it was highly directional. And so they had been expecting Mount St. Helens to erupt up. That was what most volcanoes did. They would erupt up. The effects would be sort of relatively evenly distributed around it. But instead, because of the lateral blast, because of the collapse of the mountain, most of the effects were concentrated on a 234 square mile area to the north of the mountain. And it in effect sort of spilled out across the landscape. And so the other thing to remember is that as a result of all the different volcanic processes, which is to say the landslide, the lateral blast, the ash plume, and the pyroclastic flows, what the consequence of that was that there were a lot of sort of distinct disturbance zones. So in this picture, it looks like sort of this undifferentiated brownish gray smear. But what actually happened on the ground was there were all these sort of different areas that were affected in slightly different ways. And so this is a map that shows those zones. And the ones that you can see, or the main one that you can see, is the blowdown zone, which in this map is this kind of beige color. And this was the consequence of the lateral blast flattening all the trees. And at the edge of the blowdown zone is what's called the scorch zone in orange. And this is the place where, as the lateral blast clouds, the energy from them dissipated, they lost the power to knock over the trees, but they were still hot enough to kill them. And so another name for the scorch zone that you can see is the zone of standing dead. So if you look at it, if you're at the monument and you're looking at this, what you see are all these flat trees and all these flattened trees, and then up to 17 miles from the mountain itself, these standing white snags, a ring of them sort of showing the extent of the lateral blast cloud. And the debris avalanche, or the landslide, even though it contained the most material, it was, you know, billions of tons of rock, its effects were relatively contained to this yellow area. So it had plunged down the North Fork Toutle River Valley. And the debris avalanche traveled about 14 miles down the valley and buried it in under up to 600 feet of rocky debris. And then the brown area in front of the mountain is the pumice plain, which is this sort of 6 square mile carpet of pumice up to 120 feet deep in places. And this was the result of the pyroclastic flows. And so this is what ecologists saw when they were first visiting the eruption, the blast area 2 weeks after the eruption. They'd been very, very keen to enter, but they'd had to wait a little while search and rescue personnel looked for survivors, and geologists were crawling all over the landscape trying to figure out if Mount St. Helens was going to erupt again because they'd been so taken by surprise the first time. And so what ecologists saw when they were helicoptering over was a landscape that was almost entirely gray. And so looking down at this from a helicopter, I mean, even just this picture, which is taken from the ground, they figured there was no hope of life. You know, nothing could possibly have survived the force and the power of the eruption and its destructive capabilities. But at the same time, you know, being ecologists and I guess sort of perversely motivated, they thought, what an opportunity. This was in effect one of the largest sort of unplanned ecological experiments of all time. This was a chance for them to watch life creep back into an area that had been utterly destroyed. So it's very rare for people to sort of come across these sorts of spots and be able to do this. And so they were really eager to sort of monitor the slow return of life. And so it wasn't until early June when ecologists were able to not just fly over the blast area, but land on it. And so they were getting ready to do that to sort of set up, to sort of investigate on the ground and document all this nothing. And there was a team led by a forest ecologist named Jerry Franklin. And so they flew in a helicopter to this place called Ryan Lake, which is a lake about 8 miles or so northeast of the mountain. And the helicopter lands and it kicks up all this ash. And Franklin and his colleagues, they're putting on their hazmat suits and they're being told that they have to be ready to leave in a hurry because they don't know if the mountain's going to erupt again. And so Franklin opens the door and hops out on the ground, and what does he see at his foot but a little green plant shoot? And he looked at it and recognized it as a fireweed. And this is an image of fireweed that he took later, a month or so later. So that shoot, one of the shoots that he had seen, had sort of sprouted and was continuing to grow. Now, fireweed is a very, very common plant. It's found all over the world. This is an image of mature fireweed. It can grow very tall. It's very beautiful, but it spreads very, very well. It's a classic sort of pioneer species. You know, but some gardeners like it, but some people consider it a pest. And fireweed it's called fireweed in American English because it's known for being one of the first plants to sprout in forest fires, oddly enough, in areas in forested areas that have been burned. And in England, it is sometimes known as bombweed because it was one of the first plants to sprout in craters in London during the Blitz. And so, which is to say that fireweed prefers strongly or heavily disturbed habitats. And so in this way, Mount St. Helens was perfect for fireweed, and fireweed was perfect for Mount St. Helens. And so what this image is going to show is just a spot shown over the summer. It was taken by one of Jerry Franklin's students, Peter Frenzen. So fireweed, it can grow very, very quickly. And then it grows throughout the summer, and then at the end it sprouts, and it produces thousands of seeds. And these seeds are light and fluffy. You know, they can drift far, they can drift for miles. And so in this way, fireweed is able to spread far and wide. And so, but one of the things that Franklin noted was that the fireweed that he was seeing in May could not have come from a seed. it would have been a bit of remnant root. So a survivor, some bit of fireweed had survived the eruption and been carried under the ash and then sprouted, pushing up through the ash. And as Franklin looked around, he realized that it wasn't just fireweed he was looking at. There were several other species pushing up through the ash. And this shows a huckleberry bush growing in the roots of an overturned tree. And then this is another plant called Pearly Everlasting that is in this image growing up through cracks in the ash. And so Franklin looked around and he saw evidence of life all over the place. This is just within 2 or 3 weeks of the eruption. And this was not what he had expected at all. And it wasn't just plants. There were beetles, there were insects flying through the air. They could see tracks of elk that had walked through the blast area. And so this was not what they had expected at all. They understood suddenly that rather than decades-long recovery from zero, in some places the post-eruption community response would be rapid and diverse, and more to the point, it would just be full of surprises. And so this only sort of redoubled their urge to study it. They knew that it needed to be researched because it had the potential to overturn a lot of accepted dogma about how plants and animals respond to disturbance. And so in part because of scientists' efforts, the Mount St. Helens National Volcanic Monument was created in 1982. And the monument today is about 110,000 acres, most of which are north of the mountain. And it's been set aside as a place for, as the language says, geologic forces and ecological succession to continue substantially unimpeded. So the idea was that they would take this, fairly sizable patch of land and they would just let it do what it would do. And scientists would watch and then they would learn from it. And subsequent research has shown that there are two main influencers to the initial response of life after the eruption at Mount St. Helens. And these were survivors and colonizers. And so survivors were what they called biological legacies from the pre-eruption biological community. So these might be small mammals or amphibians or plants like the fireweed that were able to grow and persist. But they could also be structures, like dead things, like trunks, like the root wads the huckleberry was growing in, that could serve as shelter for plants. And then, the point is that the survivors would come from within the blast area, and then colonizers would be things that arrived from outside the blast area. So it would be this sort of dynamic between things that came from within and things that arrived from without. And so within the sort of survivor colonizer framework, in the decades that followed, two main mascots sort of emerged. And the sort of classic survivor and the classic colonizer. And so the classic survivor is an animal called the northern pocket gopher. And the classic colonizer is a plant called the prairie lupin. And you can read about the northern pocket gopher and the prairie lupin in my book. But one of the things that happened while I was reporting the book, I was talking one day to the main biologist who's been working there since 1980. And he was saying, gosh, northern pocket gophers and prairie lupin, pocket gophers and prairie lupin. Sometimes I think that's all that anybody wants to talk about is pocket gophers and prairie lupin. Can you please talk about something else? And so while, the story of the pocket gopher and the prairie lupin are both fascinating, for the rest of the talk, I want to tell you about two species that, for me, embody, shall we say, the mountain's sort of more present modern circumstances. And these are the colonizer, which is the rainbow trout, and the survivor will be the elk. And I think of these as sort of more modern mascots. And for me, they illustrate some of the tensions inherent to the monument's aims and purpose. So yeah. So I'll start with the rainbow elk, or the rainbow trout, not the rainbow elk. So the rainbow trout is a salmonid, which means it's in the same family as the Pacific salmon that we all know and love in this area, like the Chinook and the coho. It's a very popular game fish. It's been introduced all over the world to lakes and streams and rivers and fish farms and pretty much everywhere. And at Mount St. Helens, the story of the rainbow trout is the story of Spirit Lake. And so this is Spirit Lake before the eruption, pre-1980. And it was a pretty typical sort of Pacific Northwest mountain lake at the time. It was very deep. It was clear. Its waters were very clear, which indicated that it had low nutrient levels, which means that it was, in that sense, what biologists call oligotrophic. And you can see from this picture, it's also a popular recreation site. You can see people sailing on it. There were cabins on its shore and lodges, camps. People had vacation homes and things like that. So it was a real, it was a nice place to go. People loved to go there. And this is what Spirit Lake looked like immediately after the eruption. Spirit Lake bore a lot of the brunt of the eruption's power. So when I talked about the collapse of the north flank in the debris avalanche and the size of the landslide, it was a fairly sort of complicated sort of mechanism. So what happened was the north flank slid away in 3 blocks of sort of material. And the first block of material slammed directly into Spirit Lake. And it caused a sish, which is a name for a giant wave. So all this material slams into the lake, and the disturbance throws almost water up on the surrounding hillsides. And there's a sort of apocryphal speculation that for a moment the entire lake basin may have emptied because there was so much, such was the violence of the landslide. So meanwhile, while this landslide is rumbling down towards the lake, the lateral blast clouds, since they are going so much faster than the landslide, have roared over the hillsides and knocked down all the trees. So when this giant wave sloshes up the hillsides, it gathers up all of the fallen tree trunks and dead animals and soils and everything and drags it back into the lake basin. And so what you're looking at with this lake, the sort of skim on top is actually hundreds of thousands of logs that were dragged back into the lake and were floating atop it. And so in the immediate aftermath of the eruption, the log mat, as it's called, covered about 40% of the lake's surface. And in the years since, many of the logs have sunk, but the log mat still covers about 20%, and it's pretty impressive to look at. But the main point of this is that what Spirit Lake changed pretty fundamentally as a lake. Its bottom was raised about 200 feet by all of the material that had plunged into it, and its surface area increased from about 1,300 acres to 2,200 acres, so it nearly doubled. And then, of course, there were the hundreds of thousands of logs floating atop it. And so this is the Spirit Lake that researchers faced. This is an image from the southern shore when they arrived in 1980. It was this black, stinky broth. Nothing had survived the lake. Of that they were sure. There would be no, sort of merry tales of resilient fireweed or plucky pocket gophers coming from Spirit Lake because it was anoxic. There was no oxygen in the water. They describe it as kind of sludge and sewage, and people use all sorts of nasty names for it, like a witch's brew. Slowly but surely, some bacteria would return, and they tended to be anaerobic bacteria, so they're the ones that sort of produce the great stink of mud. And also, there were 2 species of Legionella bacteria, which cause Legionnaire's disease, that were discovered at Spirit Lake, and they were both named Legionella St. Helensi and Legionella spiritensis to commemorate their origins. But the interesting thing about Spirit Lake is that even though it was a lifeless dreck, the dynamics of Spirit Lake would be pretty much completely the opposite of the land. So while the land would show the effects of the eruption in sort of the visual effects of the eruption for decades afterwards, Spirit Lake, thanks to the immediate influx of snowmelt and rain, began to clear, and it cleared relatively quickly. So what this picture shows is a sample of lake water taken from August 1980, and then one taken not even a year later in May of 1981, and you can see how much it's cleared. And so biologists began to do surveys of the microbial life in the lake, and they found that there were phytoplankton and zooplankton in 1982, and by 1983, the lake was pretty much totally clear. And so this is what Spirit Lake looked like in 2004. But it's one of those things where you have to be careful about saying the recovery of Spirit Lake, because that would seem to imply that Spirit Lake had gone back to what it was before, but it didn't. The lake was still, it was very much changed. It had gone from being oligotrophic to eutrophic, which means that instead of having low nutrients, suddenly it had very high nutrients, or higher nutrients. And so as a result of that, there were more plants, there were more organisms, more aquatic insects, more sort of amphibians and things like that. So it was a new lake. And as Spirit Lake was clearing, state biologists especially were curious to know about the state of its fish. Several lakes around Mount St. Helens had been stocked before the eruption, and Spirit Lake was one of those. It had, from I think the 1930s until 1979, the Washington Department of Fish and Game, which is now the Washington Department of Fish and Wildlife, had stocked it with 40,000 rainbow trout every year. And so, biologists were obviously curious to find out how those trout had fared. Now, they knew that all of them had died at Spirit Lake, but that wasn't true at other lakes in the blast area. And what this picture shows is a biologist doing a gillnet survey of one of the lakes in the Mount Margaret backcountry, which is just a few miles from the mountain. And so what they would do is they would put out a gillnet, they would bait it with chicken or canned tuna, and they would fly out and come back the next day and then check to see if they had caught anything. And they did. They were catching different species of trout that had been stocked in the lakes, and the fish were not doing especially well. They weren't robust, large fish, but they had survived. And so that led them to sort of, these were from surveys in just 1981 and 1982, but still nobody was really bothering to look at Spirit Lake because, all the logs and all the mess and the slow clearing of it. They would do occasional surveys, but they had never found anything. And then in 1993, a team of biologists did a survey. They did a gillnet survey, and they caught a single male rainbow trout. And they were so surprised, and they immediately named it Harry after Harry Truman, the cantankerous owner of the Mount St. Helens Lodge, who had been killed in the eruption because he refused to evacuate. And then the next year, biologists went out again and did another survey, and they caught a single female rainbow trout, which they duly named Harriet. And so they kept returning to Spirit Lake, and they kept surveying, and they would catch a few rainbow trouts each year. But then finally, 2002 was the big year. This image shows Bob Lucas and John Weinheimer, who were two biologists with the Department of Fish and Wildlife. And Lucas and Weinheimer were out fishing in the summer of 2002, and I think it was Lucas who cast a line, and suddenly this enormous rainbow trout erupts out of the water. And that, as he says, is when we knew that Spirit Lake had finally turned a corner. And so this shows him with a catch from a later year, and you can see these trout are pretty substantial trout. And that was the thing about Spirit Lake trout, rainbow trout. They were big and they were bitey. They had essentially the lake at their disposal, and so they were filling it up. They were some of the world's largest rainbows, or they were some of the largest rainbows found anywhere in the world. Real lunkers that were, the average one was 2 feet long. They weighed over 4 pounds. Where the trout were from was a mystery that is still unknown. There are a lot of sort of loose explanations of how they got there. Perhaps somebody, snuck one up and left it there. There was an Army Corps of Engineers project in 1983 to build a tunnel to allow the lake to drain. And maybe one of the engineers had brought some trout, or maybe the trout had colonized naturally when streams that had once connected to Spirit Lake reconnected periodically. But nobody really knows, although they're doing some tests now to try to find out. But whether or not the trout had gotten there naturally, they were there. And so within the sort of the ethic of investigation at Mount St. Helens, they should be studied. And so biologists started to study them. They were curious, what were they eating? Where were they spawning? And what they found was that the rainbow trout were treating Spirit Lake effectively like an ocean. They would spawn in the tributary streams, and then they would migrate out to the lake and spend a couple of years there, and then they would go back to the streams to lay eggs. And they found something else too, is that as the numbers of rainbow trout were increasing, the trout themselves were starting to shrink at a fairly constant rate. So even though there was the same overall biomass of trout in the lake, there were smaller trout because there were more of them. They were smaller fish. And so when the state learned of this, they got a little bit antsy because one of the things that happened was biologists, when they would come up to survey the lake, they would sometimes bring their friends to help them. And so word got out of these giant trout at Spirit Lake that were just waiting and begging to be caught. And so the state really wanted to open a fishery there to let recreational fishers go and fish for the trout. So far, the federal managers of the monument from the U.S. Forest Service have said no. Their reasons are largely, in addition to the monument's aims of being a research space, there's some safety issues. The log mat aforementioned would make boating around the lake very difficult. It's hard to walk down to the lake. There's only one access point at the bottom of a fairly steep mile-long trail. And so for now, at least, there's no fishery. But it shows in a way some of the tensions of what can happen when there's potentially something to exploit and no one there to exploit it. And because of this, for me, I think of rainbow trout as, this is why for me they're the new sort of mascot of a colonizer. And this shows one of the biologists at Mount St. Helens doing what he calls a hook and line survey, which is basically fishing for trout, so he can take genetic samples and measure them. And where the prairie lupin was sort of an explicitly ecological entity within the Mount St. Helens, episteme, the trout are significantly more complicated. They were introduced to Spirit Lake pre-eruption and then killed by the eruption. In effect, the mountain kind of cast them out. And then they were brought back, whether they came back on their own or were introduced by humans. It's hard to say, but the likely means, given the origins of most trout in Pacific Northwest Lake, is that they were probably brought back by people. And so because of their presence, because of their bigness and their behavior, they foster a debate about what is the monument for? What in the monument is natural and unnatural? Is it possible? Are we able to draw those lines anymore? And in that sense also, how should the monument be used? What is its purpose now, 40 years after the eruption? And so now I want to talk a little bit about the, sorry about that. I want to talk about the elk, the new survivor. So this is a bachelor herd on the Pumice Plain. The elk and large mammals like it did not fare well in the eruption at all. Unlike the pocket gopher, which could survive the eruption because it was underground, or some frogs or things like that, which were hibernating under the snow, the elk were all exposed. And so as a result, the estimates are that 1,500 were killed in the eruption, along with 5,000 deer, 200 black bears, along with an unknown number of cougars and bobcats and things like that. And so because there were no survivors, because the survivor sort of framework was not available in that sense where elk were concerned, the scientific approach would be different for large mammals like elk. There would be no search for survivors since they were all dead, but you could learn from the dead because their bodies could be found. And so this picture is of an elk skeleton that has been dug up by Evelyn Merrill, who at the time was a PhD student at the University of Washington and is now at the University of Alberta. And so what she did was she went around the blowdown zone and she would look, she and her colleagues, and they would look for these, elk carcasses. And when they found them, they would dig them up, and they would note their location. And in a way, the elk carcasses were sort of gave a kind of Pompeii-ish air to the blast area. That was how some biologists talked about them to me. It was like finding the bodies in Pompeii after Vesuvius erupted, which was an evocative, if grim, image. So in finding these skeletons, two biologists initiated a study on elk calving grounds. And so the elk herds around Mount St. Helens were fairly large, but what happens as a part of elk natural history is that when females get pregnant, they separate themselves from the herd before giving birth for safety reasons, and they kind of go off to their own private little birthing spots. And biologists wanted to know where these birthing spots were, but these were in the pre-GPS days. You couldn't just slap a little GPS tag on an elk and have a satellite tell you where it went. What most people did, what you either had to do was you put a radio collar on one, which was a kind of a large, bulky thing, and then a tech usually would have to go stand up on some exposed point and wave around an antenna and listen for the beep, 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 beep that would tell you that the elk was just in the area, and then you had to kind of find it that way. So you could do that with a radio collar and just kind of hope for the best. Or you could wait for a volcano to erupt and kill everything where it lay, and then map distributions that way, which is what people did. They mapped the skeletons, and they noted which were females with calves, and because they were able to, so often they would find a skeleton that had a little tiny sort of fetus inside, or they would find a skeleton, a female skeleton, and there'd be another smaller skeleton nearby, which had been its calf. And when they mapped them, they were able to, they learned the type of meadows that elk used to give birth. And this image shows, this is from the off-site storage of the Burke Museum. And this is what one biologist told me is the Mount St. Helens elk herd. And all those boxes hold the remains of elk that they found as they sort of surveyed the blast area. So, but not all elk had been killed in the eruption. The Mount St. Helens elk herd is about 10,000 strong. So even though it lost about 15% of its population in a moment, there was still a lot of elk kind of running around the landscape. And it wasn't long before, and so many of them had survived just outside the blast area, and it wasn't long before they began to venture back inside the blast area, within days. And so in this way, elk were some of the first animals to return to the blast area. I mean, and in this way, they're sort of perfectly suited for that. They're large and they're highly mobile. And so their initial forays into the blast area tended to be quick. They were drawn there by species like the fireweed, which are sort of elk ice cream, a nice sort of sweet plant that they love to eat. And so this, in the summers and the spring, they would come to eat the plants, and in the winter, they would forage on the grass and the seeds that people had planted in parts of the blast area for erosion control. And so their rebound in the blast area was pretty swift. In 1981, biologists counted about 200 elk, and just 4 years later, that number had tripled to more than 600 elk. And so this is a picture of a mixed herd of elk sort of wandering around the debris avalanche deposits. And so elk now are a pretty common sight in the blast area, in the pumice plain especially, and in the blowdown zone. And so, you know, having all these large mammals move through, for plants at least at first, the consequences of elk recovery were largely, they were a benefit. Elk they would eat and they would go into the blast area and they would poop. And elk droppings, which is what this shows, were sort of welcome fertilizer. And you can see here some prairie lupins growing among a pile of elk droppings. And elk also, since they range far and wide and they have very sharp hooves, they would break up the ash. And so the ash, when it got rained on and then dried, tended to form a very hard crust, which was hard for plants to grow in. But a herd of elk would walk through, and then this crust would be broken up into a much more kind of softer and welcoming medium. But the success of elk came at a cost. So as their numbers were climbing and climbing, they began to run into a limit of the amount of food that was available to them. And so in the winter, many of them would starve. WDFW, the Washington Department of Fish and Wildlife, began doing surveys for winter-killed elk in 1999, and they were finding that as many as 150 elk would starve every year, which was a fair number of elk. And the news of starving elk began to reach and upset people in communities that were just outside the monument. They didn't really like to see, I mean, although the monument was a place for nature to take its course, nobody really liked to see it take its course quite like this, in the form of a starved elk, you know, sort of flopping helplessly on the ground with its ribs showing. And so the state game agency began to initiate a supplemental feeding program in the winter, and they would bring hay up from Oregon. And in 2019, they received about $310,000 in grants from the Rocky Mountain Elk Foundation for habitat enhancement, which was sort of this winter forage, bringing and depositing food for the elk to eat. And so the elk herd after that has since sort of stabilized. And in that sense, now their influence has begun to shift 35, 40 years later from being largely positive to more mixed. And so what this picture shows is a tree, a young evergreen tree that has been heavily browsed by elk. You can see the top is sort of more of a classic tree shape, but the middle and the bottom of it have been pruned pretty significantly by elk teeth. And so this, in a sense then, they became, you know, where plants would return, the elk kind of stopped them in a way. Because the tree that they have browsed on here, this evergreen tree, is one of the newest arrivals to the blast area. And the arrival of evergreen trees and conifers like this is supposed to signal sort of a new stage in succession. But if the trees arrive and the elk eat them and they are not able to thrive, then the area is sort of held in a kind of perpetual state of pause. So not only were they heavily browsing on trees, but even acts before that had been good, like elk walking across the landscape and breaking up the ash, now become a little more neutral at best, because now they're walking across the landscape and stepping on plants and tearing up plants. And one biologist said to me that you can look at a patch of land that elk have walked across, and it's like ecological succession has been set back 10 years. And so in a way, to return to the original sort of purpose of the monument, which was ecological succession to continue unimpeded, this was definitely ecological succession interrupted, but was it impeded? And that's sort of the question that people are wrestling with now. And as happens when there are difficult questions, people, they want to fix them. And so this is not for the first time. In 1982, as elk were beginning to return to the landscape in large numbers, the state Fish and Game instituted a hunt to try to drive the elk out of the monument. But what they ended up doing was driving the elk into the monument. And so the hunt went on for a couple of years, and the elk took up refuge within the monument where people weren't allowed to hunt. And so the elk knew a refuge when they found one. So, if you could hunt elk outside the monument, the elk were like, fine, we'll just stay in the monument. And so that, they continued to eat and stomp around. And so finally in 2005, monument ecologists had enough of this, and they began to advocate for a limited hunt to drive the elk from the heart of the monument back out to more the edge of it, where they might be accessible by other hunters. So it didn't quite work out that way. What happened was, instead of a limited hunt over a small geographic area in the heart of the monument, there was a more substantial hunt within the fringe of the monument, and it is still ongoing. And so the elk have stayed in the pumice plain, and they basically show no signs of leaving. And so that, in a way, is why, I like to think of elk as the new mascot of the survivor, because there's such a test on the phrase ecological succession substantially unimpeded. And so you ask, unimpeded by whom? The elk have always been a natural part of the landscape at Mount St. Helens. they came back to the monument on their own, but they came back and they did a little bit too well because of actions outside the monument. And in this way, elk especially sort of, they are what, for me, kind of combine the landscape within the monument with the landscape outside the monument. And in this, they show, for me, how Mount St. Helens will always be a very sort of beautiful, kind of complex space. You know, it's not as simple, straightforward. We're just going to look at, you know, how life responds to the eruption. But to study how life responds to the eruption, you have to ask all these complicated questions about, you know, how do you think it should respond? If it's responding in ways that you aren't expecting, what do you do? Do you let it continue going, or do you, you know, step in and try to sort of quote unquote fix it? And so I want to close with this image, which is a time lapse from NASA from 1979 to 2016, and ask, you know, I like to return to the question of like, what's new at Mount St. Helens and what are the sort of lessons that we can learn from Mount St. Helens, frankly, especially now as we're living through, many of us, a disaster of, you know, pretty unexpected or unanticipated, unprecedented proportions. And so this shows the blast area sort of getting steadily greener as the years go by. And so when, you know, people would ask, well, what did you learn from this? I would think, well, you know, what did I learn? You know, things will always come back, even in the face of a seemingly unfathomable disaster. I mean, people, when they first saw the mountain, they thought, you know, it's like a hellscape, a moon. But life was there, and it was still kicking along. The thing is that it may not come back as you expect it to, or even want to. And then you as a person, as a manager, have to ask how you feel about that, and have to sort of confront sort of perhaps aspects of your powerlessness. But the other thing is that it's full of surprises, and that there will always be sort of new things to see and new things to learn. And so with that, I'll close, and I'll say thank you all for joining me. Happy to take questions. And yeah, the book is available now from a lot of bookstores and online places. And yeah, thanks. So thank you.
Thank you very much, Eric. And we forgot to ask or tell the audience that in general, the museum would be able to help with those book sales, but we're not open, so that's not going to work now. So I would encourage everyone interested to purchase his books. I've got the first two, and this one was very great. Lots of comments, Eric, about how interesting it was, and yes, some questions.
Great.
The first one is the last one that was asked, but does the Crater Lake area show what may be the future of Mount St. Helens?
Gosh, that's a good question. I would say, I mean, the future in terms of the biology, to some degree, yes. I mean, there's some differences in latitude. One of the things that's interesting about Mount St. Helens, because it is so active, and I think the thing with Crater Lake is, since it's an extinct volcano or a collapsed volcano, is there's some elements of Mount St. Helens biology that are kind of overwritten by its volcanic activity. So one of the things that's kind of a puzzle to folks is that the tree line at Mount St. Helens is lower than it would be at is lower than parallel tree lines at Mount Adams and Mount Rainier. And sort of the reason people think that might be is because Mount St. Helens erupts and knocks the trees back, and so they don't quite have time to get all the way up as they have at other less active mountains. But I think in a lot of ways, I mean, another thing is that question, that's a good question. It gets to one of the things about Mount St. Helens that was interesting is that it wasn't an interesting mountain until it erupted. And one of the things that biologists who were studying the mountain initially really struggled with was that there wasn't a lot of information about what had been there before, because people just assumed it was like Mount Adams and Mount Rainier. And so, yes, in a lot of ways, Crater Lake kind of shows the future, but in probably some interesting, quirky ways, it doesn't. And so that's where, sort of continued attention at Mount St. Helens is good.
Yeah. Very good. Don, again, thanked you and said it was been very informative tonight. He said he did a trail run around the Lewitt Trail in a day some years back.
Mm-hmm.
It's amazing to see so many eco zones and so much life amidst all the piles and gullies of debris and plains of pumice.
Yes.
And he's looking forward to your book.
Oh, thank you.
Yeah. Another question about the excuse me. Is it true that this is one area where new glaciers are actually forming as opposed to melting?
Yes, there is the crater glacier. That's a great question. There's the crater glacier within the crater that kind of folds behind the new dome. So the interesting thing about the eruption, so a little bit of eruption trivia, is that the 1980 eruption actually didn't end with the catastrophic eruption. The mountain stayed volcanically active for another 6 years. So the eruption is officially sort of considered to have gone from March 1980 until 1986. Wow. And part of the elements of the sort of latter eruptive activity was dome building. And then, of course, I don't know, people probably remember from 2004 to 2008, the series of eruptions that were more dome building eruptions. And so now the dome, I think the new dome is about 1,000 feet tall. And so there's a glacier that formed behind the dome. And because it's behind the dome and sort of shielded by the crater walls, it doesn't get the same amount of sun exposure that's melting all the other glaciers all over the Pacific Northwest that you've probably heard about. And so it's one of the only glaciers in this region that is still growing. And you know, you can watch its kind of lobes go around the dome and kind of meet in the front. So it's like a giant ring. It's pretty cool.
That's interesting. Back to the lake, yeah. Deb Barker is asking, could clumsy birds have brought the trout to Spirit Lake?
That seems, I mean, I will say first, one thing that Mount St. Helens, if we've learned anything from Mount St. Helens, it's that you don't foreclose on any possible explanation. So yes, you could say, yeah, it's possible that an osprey or a bald eagle was flying over the lake with a half alive trout and it dropped it and the trout lived, and then another one showed up and somehow they bred. My own sense, and I say this as a non-fish biologist, so this is, with a hearty grain of salt, is that I would guess that it was probably multiple introductions. Most of them sort of surreptitious, because in invasive species biology or introduced species biology, one of the things that is really important is what's called kind of propagule pressure. So you need a lot of things for a species to get a lot of individuals before a species can really get a foothold. And so, the one trout that they found in 1993 probably was not the only trout in the lake at that time. There had probably been, probably dozens of trout, maybe more, kind of lurking around that they finally managed to catch one. I'm afraid, in a way, that we're seeing a kind of horrible parallel right now with coronavirus, where that for each case detected, there are 10 or so that probably aren't. So I would guess that with the trout, there were a lot of people bringing in a few trout and hoping for the best, and then finally, after they met some threshold, and the numbers just exploded.
Interesting. Back to the elk. Did cougars or other wild animals come in and eat the the elk?
Yeah, there are a lot of cougars. I don't know about a lot, but one of the things. But there are cougars there. I don't think they're enough to really have a significant population effect. But the arrival of large mammals like cougars or large predators like cougars and black bears is one of the more interesting newer developments at Mount St. Helens. And one of the main biologists work there is a fellow named Charlie Crisafulli, and Charlie says that Mount St. Helens would actually be a perfect place for wolves because it's a large open area. There isn't a ton of livestock. There are lots of elk just waiting to be eaten. And the nearest pack, I think, is something 90 miles away. I think it's the Teanaway pack. And so he guesses, Charlie does, that wolves will get there within 10 or 20 years. And when they do, you know, they're going to fare pretty well. But yeah, so the elk have an interesting future.
Yeah, I think so. Back to the lake, and you talked about that a little bit, but in the first picture, we saw that, you know, big, beautiful lake, and then later there were pictures of smaller lakes. So have they been renamed? Are they
Oh yeah.
intersecting with each other, or what's going on with the different ones now?
So Spirit Lake is, actually, let me go. Is it okay if I share my screen again?
Sure.
Let's go back to this. So you can see here, I'll go, so can you see my cursor, Deborah Faye? So here's Spirit Lake.
Yes, yes.
And, whoops. And this here is Coldwater Lake.
Oh.
And this is Castle Lake. And these are two new lakes that were formed by the debris avalanche, which had, you know, rumbled down the North Fork of the Toutle and blocked and it acts as basically a massive dam. So Spirit Lake used to empty out the North Fork of the Toutle before the debris avalanche blocked its old outlet. And there's an interesting story behind that about, that was why they built a tunnel. The U.S. Army Corps of Engineers, built a tunnel that goes to South Coldwater Creek. But anyway, so there are several new lakes, the Coldwater Lake and Castle Lake. And then in this area here, it's called Hummocks. I don't know if anybody's been there. There's a trail, about a 2-mile trail at Hummocks, and it takes you among hundreds of new ponds. And so all of these ponds formed in remnants of the debris avalanche. And so they're essentially an experiment within an experiment of, you know, the return of amphibians like frogs and toads and salamanders and things. And the dynamics of those ponds are all pretty crazy. I mean, some of them dry out in the course of a couple of months. Some of them are perennial, they last throughout the year. And so that's one of the more interesting research spots for biologists right now, is looking at those new water bodies.
That's great. How about people? Are they fishing those lakes? Are they rebuilding, or are they allowed to do that?
There's fishing at Coldwater Lake, and I think you can fish at Meta Lake, which is another lake on the east side. And they're fish in those lakes. You know, they're still. I know that Coldwater Lake is stocked, and people, you know, you can drive a boat around it and fish, and it's supposed to be pretty nice. I'm not sure. You're not technically allowed to fish in the backcountry, in the Mount Margaret backcountry, where there are a series of small lakes. And I know there are other sort of, fishing opportunities like up on the Green River and stuff like that.
And is your book available at all of our local books, like at Paper Boat Books? Do you know? I
don't know about Paper Boat. I'm not sure. I think so. I know it can definitely be ordered, and it's at like Elliott Bay and the U bookstore in the U District and things. Yeah, it's around. I think it can be found.
All right, that's good. We needed the encouragement.
Yes.
Another question about since Mount St. Helens was not analyzed prior to the eruption, do we know why the land failure right before the blast happened, where it did, and was it soils, or was it some other anomaly to make that area collapse?
Oh, well, it was basically because of the magma chamber. So as the magma chamber, so here's the mountain, here's the magma chamber growing, and pushing out this rock and making the rock really unstable. And so it's kind of, I think miners talk about the angle of repose, the point at which a rock will, the angle at which a rock falls. And so with the earthquake especially, so you have this highly unstable bulge, it's just growing and growing, and then it gets shaken, and then off it goes. And then of course all the stuff in the magma chamber blows out like that. So there was nothing it wasn't anything specific about the mountain. It was more the volcanic process of the magma chamber growing, the bulge being destabilized, and then the earthquake causing it to collapse.
We're learning a lot from you, Eric. I appreciate that.
Yeah.
I wanted to, oh, I just had another thought on my mind. What was it? Just a reminder about, I don't know, but I'm sorry.
Oh, no.
Missed it. How about Mount Rainier? Do we have any information that might scare us about Mount Rainier?
I don't think so. I think one of the benefits to really come out of Mount St. Helens was that geologists learned a lot about what to look for in the lead into an eruption. And so it really helped them refine their sort of criteria of alarm. And so I don't think that, I mean, there's nothing alarming about Mount Rainier right now. One of the things, I mean, if you're curious, you can go to the Cascades Volcano Observatory site, which is a site run by the USGS, and they have alerts. You know, they show you the status of all of our area volcanoes, and I think most of them right now are quiet.
Okay, that's good. And a final question maybe. So Paradise is not a place that a magma chamber could develop?
Oh gosh, well, I don't know. I mean, the Earth does its things, so I wouldn't put it past. I wouldn't say no. Also, I'm not a geologist, so I'm probably not the person to ask.
All right, that's good. Well, based on what you said, we only have another 100. It's been 40 years, so we only have another 100 years before Mount St. Helens comes alive again. Is that?
Yeah. Well, I mean, we already had one once. We had the 2004 to 2008. So
Right.
even just 24 years after that, there was one. So we got a little more time.
Okay. We
But
can alert our grandchildren.
yeah, we can tell them to be on the lookout. For the
That's
next big one.
Oh, that's really great. Thank you so much, Eric, and everyone is thanking you. I hope you might be interested in reading these comments, but just
yes.
an awful lot of appreciation. And Tasia has a last final announcement, I think, before everyone leaves. Please remember that we'll be back on next month, second Thursday at 6 o'clock. Watch for the announcement. You're on, Tasia.
Thanks, Dorothy. Yeah, I just wanted to end by thanking everyone again for attending the presentation. If you want to get notifications about this program and you're not already signed up for our mailing list or not following us on Facebook, I encourage you to sign up for those things so you can hear more about the programs in the coming months. And also, if you're so inclined, if you like this program, would like to see it continue and want to support it, if you are inclined to give us a donation, we would be really grateful for that as well. To do that, you can just go to our website, loghousemuseum.org, and find the donate link. So once again, thank you to everyone who attended. Thank you to Eric for sharing this information about your book.
Thank you to all of you. Yeah.
And we hope to see you all at next month's presentation.
Thank you, Tasia, and good luck to you in your new job.
Thank
We
you.
will miss you here
Thank
and
you.
at the museum. Good night, everybody. Thanks for being with us.
Good night. Thank you.
Good night.